sir.
Good morning, everyone.
Good morning, sir.
Good morning.
Good morning, dear participants. We are waiting for our today's speakers. Soon he is going to join us, and then we will start the session.
ब्रजेश जी नमस्कार। ओके।
Good morning, dear sirs, and good morning, sir. Sir has just joined us. Am I audible?
Okay.
Yeah.
Yeah, audible.
So, yes, welcome, sir, in this short
welcome.
course of biodiversity conservation and sustainable development. Dear participants, today with us, I'm going to, it's my honor to introduce our today's first and as well as second session speaker, Professor A L Ramanathan. Dr. A L Ramanathan is a professor at the School of Environmental Sciences, Jawaharlal Nehru University, New Delhi. Sir, research and journey commenced with a focus on various sites of the river basin geochemistry. Sir later on subsequently explained his research and endeavors to encompass coastal ecosystem, particularly estuaries, mangroves, and coral reefs. Professor Ramanathan portfolios includes pivotal projects such as hydrogeochemistry of groundwater, the impact of land use change and our exploitation on groundwater, quality of surveys and groundwater interaction in coastal areas and floodplains, especially in Gangas and Yamuna rivers, and the effects of climate change on Indian glaciers, among others. In addition to his contribution to hydrogeochemistry and biogeochemistry, Professor Ramanathan has dedicated significant efforts to understand the dynamic of Himalayan glaciers. He boasts a publication record of over 75 papers in various peer-reviewed journals, along with the authorship of 7 books published by reputable publishers like Springer, Belcoma, in addition to numerous book chapters. Professor Ramanathan has organized and led 11 international and national workshop trainings, programs, and conferences on the topic of significant importance. His research has received substantial support from both national entities such as UGC, DST, MOEF, among others, and international funding organizations like SIDA, IFS, FORMS, and Indo-Australian funds, among others. He has garnered numerous awards and patents for his work. Professor Ramanathan has undertaken collaborative projects with institutions from France, Sweden, Australia, and Russia. Under his guidance, 15 PhD candidates and more than 15 MPhil students have completed their degrees and are currently positioned well both within India and abroad. With these introductory remarks, I would like to extend a warm invitation to Professor A. L. Ramanathan for today's lectures. Over to you, sir.
Thank you, Kalim ji, for what is it? Oh, can you thank you? Ji? Okay, okay. Thank you for that. So I am happy to be here. Some echo is coming there. Is there any problem?
सर
Echo is coming.
सर आप एक माइक ऑफ कर दें सर प्लीज दोनों का माइक ऑन है ना
मेरा तो नहीं है. I have only one mic. Okay.
Log in from two.
अच्छा,
Yes, you need to mute the mic of one.
Oh, I don't know. So what that? Where is that? I don't.
Yes, it said that.
Okay. Okay. Now it is one. I think. Now it is one. Okay.
No, it's okay, sir.
Now it. Thank you. So I will. Can you see my slides?
नो सर
Okay.
No, sir.
Okay. What is it? Where you are? Now you can see the screen.
यस
Yes, sir. Yes, sir. Yes, sir.
Okay. Thank you. Thank you. I'm happy to interact with you, the faculties from different universities working in different aspects of environmental science and water resources or other related issues. So we have been working in this glacier from 2010 onwards. Earlier we are working on the rivers, then on the estuaries and the coastal and groundwaters. We have started this program in JNU. It's a team of glaciology team we developed, and then we started this work. So just before I start into that, I'll just give you some of the brief introductions about these things. So as you know very well that we have the continental glaciers and the alpine glaciers, basically valley glaciers, and the which is spread over the continent long area, that ice sheets like Antarctica, Greenland, and all those things. And then Himalaya comes under the valley glaciers. Okay, so we have then we have the ice caps, then we have the sea ice, floating ice, and then continental shelf ice. So in the Antarctica, Arctic regions. So our group also worked in different poles, 3 poles. We try to work on that and try to link the connections between these 3 cryospheric system. So the glaciers are mainly is a massive moving river that is moving mass of ice that forms when snow accumulates over the time and then compress in its own weight. They are found in mountainous regions all over the world, and they also in the Antarctica and continental. It's a natural reservoir storing the water, fresh water. So that is why, see, you know, the systems in India that we have peninsular rivers and the Himalayan rivers. The peninsular rivers, we have the different eco-hydrological system. And then Himalayan rivers, which have the eco-hydrological as well as cryospheric system. So there is a marked difference between this. We have also got the perennial rivers and the peninsular rivers, especially Godavari, Krishna, Mahanadi, and all those things. So here also we have the perennial rivers. Most of them are perennial rivers in the Himalayas. The main reason is that the influence of the monsoon westerlies in the regions. And then during the non-monsoon seasons, the forest ecosystems in the Western Ghats and the Eastern Ghats plays a major role that is uh, uh, supplying, you know, the origin of the rivers. If you see the origin of the rivers, basically one is from the, all are from the mountains, and one is from the cryospheric mountains, one is from the normal mountains, which is having vegetations. So here the origin is the glacier for these Himalayan rivers. The origin for the peninsular rivers is the forest ecosystem, that is the springs. You know very well that we have the first order stream, second order stream, third order stream, fourth order stream, then tributaries combined together form the main river, and then the main river will be forming the distributaries when it sluggish in the movement of runoff in the region, become the distributaries. So here the origin is combination of these things in the Himalayas, because during the non-monsoon seasons, and then the meltwaters comes, and then because it is ice, it may not melt, the temperature is less. So the downstream regions like the lesser Himalayas, we have the vegetation, the eco-hydrology will supply the water. So that is there is a different in sources, different in the flow of waters. So in that context, if you see that both are important, and the mighty one is in the Himalayas, because it feeds not only our country. There are 14 countries depend upon the Hindu Kush Karakoram Himalayas. So Ganges, Brahmaputra, Indus, Bias, all those things, major agricultural system, water storage system in these regions. So we are also we require the river flow in the non-monsoon, that is the base flow or the ecological flow, the environmental flow, to recharge the groundwater, and then the river flow. That is why in the delta region, if you see that, and even there is no flow of water, there will be a lot of groundwater, and hence become the rice bowl. See, most of the deltas are rice bowls, and because it holds a lot of water. And then we also produce a lot of hydropower. You might have seen that in the Himalayas nowadays, a lot of micro and macro hydropower generations are happening. That becomes self-sufficient because of the population we need. At least this is relatively environmental friendly compared to that of the coal and other things. And also the quality of the groundwater is a very pure water coming out of that, unless until you pollute with the black carbon or the organic shoots or any other pollutants, trans-Himalayans or the transboundary pollutions comes. Otherwise, it will be most of the glaciers are having the fresh waters, and that is good for the drinking, irrigation. You can go to the Himalayas or even go to the Western Ghats, and then you go to the spring, and then directly you can drink. There is no other way when you are in the field. It's a very nice water. Earlier also, you might have all of us drunk the pond water in the village or the river water in the villages. Glacier melt also transport nowadays sediments, pollutants also, contaminants also. And also it is very important one thing, it contributes to sediment, which transport, for example, from the Gangotri to the Hooghly or the Ganges Delta. So that makes them fertile. And also the productivity of the ocean depends upon the input of the sediments coming from the Ganga. So the glaciers are the perennial sources. That is why we are bothered about them. If it is loses its because some of the glaciers in Iceland and in Europe, they are now become the museums because it is retreated, and then there is no more snow is coming in that regions. So we don't want that such a type of situation. Then there is no perenniality of the rivers in the Himalayas. And for example, if you take the Brahmaputra, we are getting with all the perennial sources from the Tibetan glaciers. So the Brahmaputra, suppose if there is the biggest dam, the Sangpo River, they call it there in the China. If they divert, they are almost completed the dam. They diverted this water, then the Brahmaputra is no more flooding and no more perennial river. It will be there. So there are a lot of issues that transboundary issues are also there. And then so that we study the glaciers using various techniques, remote sensing techniques, field observations, modeling. And we need a lot of people to work on that one, because there's no, we need chemists, we need biologists, we need statisticians, we need modelers, we need physicists. So chemists, all the geologists, environmental scientist, because it is interdisciplinary. Nature is having always interdisciplinary approaches. So because of climate change, also we should address these things. The critical link between the glaciers and sustainability of water resource, I mean, the regional differences. So you can see the differences. There are small glaciers, there are rock glaciers, there are glaciers which are advancing, there are glaciers which are retreating. So it depends upon the region, the climate, elevations, and how we are impacting. Anthropogenic impacts are there. Mountain glaciers topography constrains the natural glaciers for water resource from modifying climate required for sustained glaciers. So that is what I told you, the springs. Generally, if you see the ancestral, our traditional knowledge, if you see all our ancestors in the mountain regions, they all tell the weather conditions depend upon the flow of spring, volume of spring, and the timing and the spatial and temporal variation of the spring. So they will be able to tell us this time drought is going to come, this time enough water is there, and this time there is a rainfall is excess. All those things, if you talk to the tribal peoples or the people living in the Western Ghats or in the people, they know all these things, how these things are happening. In the Andaman, if you go to the tribes, they talk to them, they will know how the springs are drying, why it is drying, all those things. And we call it as Asian water towers. That is Hindu Kush, Karakoram, Himalayas is the Asian water tower. And then, so this is how the snow that is converted into the snow will become the fern because of the density difference by compressions. So today the snowfall is happening means next year only it will convert it into the fern. Next 3-4 years it will be in the fern and then become the granular ice 3 and 4, and then 5 it will become a solid ice in the 5th year. And then so the age of the snow will be less, slow granular fern will be slightly higher, and the ice will be higher. Some of them goes up to Himalayas. If you see the 500 years or so, it goes in the other Antarctica and all, it will be go up to 10,000 years or little glacial period. Long ages will be there in that one. So how this is the physics by which the flakes are converted into a solid ice. So this is how this snowfall falls and accumulates, and then the ice compacts, flakes undergo the pressure solutions. So it will be having the, if it is loose snow, then 90% of the air, granular snow 50% of the air, fern 25% of the air, fine grained ice, that is 20% air and bubbles, and then coarse grained ice, it will be less than 5% or bubble. So it goes out to 1,30,000 years ages also we can have these things, the coarser the grain. So when it is compacted, it will be stable for more than, unless until the temperature increases, it will be stable. So it's like our bank deposits, we used to have this, no, earlier. Nowadays we have different mutual funds and all those things. Earlier, traditionally, our knowledge goes to only the savings account, and then the what is monthly payment bank account, then fixed deposit accounts. So we will be able to suppose if you are getting a salary of 5,000, you can spend the 50% for your domestic purpose, and then plan the remaining for the future, and then store it. When there is emergency like education, marriage and all, you will take the fixed deposit or the recurring deposits, whatever is there. Similarly for us also, 50% of the ice snowfall should be melting during the summer, and then make the river perennial and flow and recharge the groundwater and supply water to the downstream regions along with the nutrients and the sediments. 50% has to be stored. When there is a dry period, when there is a El Nino year, when there is a drought period, then we should take the emergency, that is the ice. But now what we are doing is that because of the rising in temperatures, we are taking the emergency ice. Ice is started melting in most of the regions. So this is how this problem is rising, and we are all very concerned. The government of India is having different projects to address these things and address how to understand and then conserve this in the region. So this is how the ages will be going like that. So this is how the alpine continental glaciers, ice sheets, like you can see the 3 kilometer thickness, and then ice shelves and the sea ice. This is plays a major significant role. Maybe, I don't know, maybe you might have studied in the +2 if you are not a geology or geography students or environmental science. The sea ice, it's very important for the ocean circulation patterns and then the climate change. If there is no sea ice, then there is no nutrient supply from different parts of the ocean, and the productivity of the ocean will be decreasing in the regions. And then we have the frost region, that is the permafrost. Then we have the glaciers. So in Himalayas, generally 10 years back, above 3,000 meters, we get a glaciers. Now it is going up 4,000 meters. It is really a concern for us. And then ages, if you see the ages, you see that glacier and ice caps months to century. Frozen ground, that is Siberia, Alaska. Then we are having in the Sikkim, and then in the Leh Ladakh, that are frozen grounds, which is from the millennium, century to millennium years. So the ages varies, and then that's why we are very bothered about this. Glaciers are losing. We are losing the glaciers due to climate change and rising in temperatures. That's what we are worried, and we are studying all those things. If you see historically, geological, I mean to say geologically historical, not historical in the terms of 1,000 years or 200 years. So from the Archean period onwards, there will be warmer, and that is the glacial, interglacial periods are there in that regions. Now that is interglacial period, we are there. That's why it is warmer. And then little ice age is there in the 65 million years of ice age. Then 20,000 years, 18,000, 20,000, the little ice age is there. So after that, that is where the sea level rises, sea level reduces, glaciers formed, glacials stored. So it is historically happening, but those things are happening in a millions of years. But now it is happening in hundreds of years or tens of years. That is why we are bothered about and study this thing. So we are working on these different aspects, but a lot of things has to be addressed. But our group started with this work in this region. So glaciers, how they move, you know that the rivers moving differently, air moving differently, and the glacier moves differently. Glacier transport material differently, river transport material differently. So suspension, saltation, tractions, this and the solutions. These are the major process by which they transport materials. That's why all along the river system, you will get the productivity. If it is a plateau, if it is a floodplain. So throughout the river, for example, Ganges, you take throughout the river system, you will get productivity areas, agriculture activities, horticulture activities, forest system, lake formations, aquaculture productivity, aquatic systems. All these things depends upon this, how they transport the material. They not only transport the material in the solution form, not only water, it also transport solid dissolved ions, then sediments, finer sediments, coarser sediments, clay materials, which is having cation, anion exchange capacity, organic matter content, fluoric acids in them, and then the internal deformations process by which the glaciers constantly deform and then move. There is a top and bottom of the glaciers moves differently, and the melting and freezing also happening. Then we have the zones of accumulations where there's accumulation is taking place. It's like a geomorphological feature. It's like a basin. You develop naturally the mountain system due to tectonic activities and other processes. They develop a basin type of systems on the top of the mountains. If you go to the from Manali towards the Leh or Manali towards the Gaza, you can see our Sikkim area from that. If you go in the Kashmir area, you go there, you can see that one. The Ladakh area, if you go by the plane, you can see that just Ladakh airport, just above the Ladakh airport, when the plane lifts, you will see the glaciers directly on the glaciers. It goes there. You can see the accumulation zones in the top of the glaciers, and then the ablation zones, and then the equilibrium line, which is boundary between the accumulation and the zero mass balance occurs in these regions. So this is how our Himalayan systems, this is the accumulation zones, headwaters. So there is a crevasses will be there in these regions, and then This is the circuit, that is the basin in which the snow will form and then undergoes all this metamorphism and converted into ice, and then due to its own pressure it started to moving. And if it is don't move, then it is, we call it ice caps. If it moves, then it becomes a glacier. And then it moves, and then it forms the lakes and other things, and then it moves. Zone of ablation, zone of accumulations. That is, ablation zone is there, and then the flow. This is how the stretches. So approaching the glacier is. So we have to go, if you want to study that, you have to go up to at least this area. If you are not going to this area, at least you have to go to this area to find out the mass balance by putting the stakes and then digging the cores. And the field experiment is slightly difficult, and but if you are interested and risky, and you take all precautions, and we need a dedicated team of research scholars, because basically field work is done basically by them only, who stays there for months and months and do all those things. And this is how the close look, if you look at these accumulations takes place, you can see the ice and then tributary glaciers, main glaciers, crevasses. You will get the crevasses. This is very dangerous. When you fall into that one, sometimes it goes up to hundreds of meters, 200 meters, dark side, and you cannot come up in that regions. So that is, and then moraines, all those things will be there. So the glacier dynamics, the climate, it's how the moves, how the retreat, all those things comes under the climate. Climate is the one of the thing. Precipitation, how much amount of precipitation is there, solid precipitation. If there is a liquid precipitation, that is also a problem for the health of the glaciers. And then the topography, we need a slope for the movement of the ice. And then the bedrock, typically it has to be a stable bedrock, should not be sedimentary, then it will be not be able to stand for millions of years. And then it started to erosion. I told you the traction method, basically the glacier transport by traction and deposition. They erode that turn, and then that creates sometimes the landslides and the avalanches, and the flooding and the sea level rise will be there. Then field observations, that is what we are doing. Field observations, and then you can do the we go directly, because without field observation you cannot verify your modeling data or remote sensing data. So somebody has to go to the field at least sometimes in that one. So we have been doing it from the 2005 onwards, with the help of research scholars and master students who are able to spend their research time in the field and the lab and the thesis writing. And the computer models help to stimulate the behavior of the glaciers. So we need a people, all these. Then along with that, biogeochemical people, microbiology people, paleontologist, botanist, all those people are required to study these regions. So this is how this, when you go from Manali, you can see this type of regions. If you cross the Renuka lake, that is artificial lake they created for the hydropower. So if you cross that immediately before Manali, you will find this a lot of waterfalls coming from the glaciers regions. And then you will be getting the Tarn lakes, Patterson lakes in the town. When it is accumulation zone, it is called the Tarn lakes, otherwise it's called Patterson. Then the peak area is the Irity, and then the hanging valley systems and the waterfalls. This is how the U-shaped valley will be, and V-shaped valley. If it's a river and a glacier, it develops different things. This is the Cirque region, which is Cirque and Tarn are linked to the Irity, Horn. They are all linked together. So this is how the formations looks like when it is glacial retreated. So tilts and tilloids, which is able to, for example, if you go to Gondwana in the cold regions of this Madhya Pradesh and this Nagpur area, you will find these tilts, which shows that there is during the little ice age, there are a lot of ice was there. Later, it becomes swampy and then become vegetative and then and this vegetation will be converted into coal formations in these regions. So it keeps on shifting from place to place, and this is how the glacier moves. It's like sometimes you are leveling. You might have seen the land was leveled by a tractor with the front leveler. So in between the two sheets, you will find that sand will be deposited. Similar to that, only when the glacier is moving, there will be the medial moraine, which form the sediments, and both the things will come. This is the tributary river. This is the main river, main glacier. Sorry, tributary glacier, main glacier, and then we got the lateral moraine because it's deposit. When it moves, it will deposit. It will make that, and then push the sediment sidewards so that it forms the pathway and then moves towards it. And then terminal moraines, ground moraines, recessional moraines, outwash moraines. So these are all we will be paleo glaciation. If you want to study, you should study all those things. How the dating them, and then OSL dating, you do that, and then find out the ages, and then tell that Gangotri was here in 1967, Gangotri was here 1930, it retreated this much. The retreat rate is so fast, that means in the next 10 years or 100 years, it is going to retreat here. So then what the precaution you have to take, all these things we have to study using this. So this is how the Piternatras lakes and the Ton lakes are looks like, and this is how this permafrost. You can go to Leh Ladakh. If you go to that lake, India-China border lake, the famous lake is there, and then before that you will find a lot of permafrost in the regions. So it's a permanently frozen ground for more than almost a year. So that's why the age of permafrost is equal more than that of the glaciers and the continental ice in these regions. So the permafrost regions is very important because when it is defrost, it will release also of CO2 into the atmosphere, which stored there, and then the land become unstable because of rising temperature in these regions. And this is the circu regions, and you can find this in the, if you walk around, if you go by flight or you go by the side roads of this Leh Ladakh or Gaza or Sikkim, you will find all these features in the regions. And this is the arity. This is the arity. You can see that one. This is the arity. You can see that in the field. We have to date. We have to map. Somebody, people, geomorphologists and geologists will map the glaciers. For them, they need to understand where is arity, where is circu, where is Khan, where is ice dammed lake. This has become ice dam lake. This has become dangerous. Uttarakhand and all, you might have seen the glacial lake outburst floods are there, and then all those things which is there. And then this is how you can see the in the, I told you the Renuka lake after crossing Manali. Before Manali, you will get that one. And then you will find the U-shaped valley of the glacier, where this glacier input is there, and then form the valley. It forms the small rivers, streams, first order stream, second order stream. And this will come to, for example, if you go to the glacier where we are looking, first we are getting the Chotadara lake. Chotadara's Chota Shigri Glacier, Bada Shigri Glacier. From that, the meltwater comes, and then the Chotadara stream, and Chotadara streams finally form to the Bias. So then the Bias will go to that. So similarly, that a lot of systems will be developed in that one, and this water is coming to the dam to form the lakes in the Renuka Lake in the region. So this is how the Hanging Valley and the waterfall systems, beautiful systems are there in the regions. And as I told you, how this paleo movement of the glaciers, how the direction of the glacier is changing. So we will, like our any geologist, they knows that how do you just touch on the rocks, you will tell that movement of the fault plane, where it is there, which direction it is moved. That makes the smoothened surface. It shows the glacier was moving earlier this directions and then retreated. So this is how the striations and grooves, which helps to identify the paleoglaciation in the regions. So the global ice loss in the region, if you see that one, we are losing almost mountain glaciers, alpine glaciers, Cascadian Mountain, Alps in the Europe, and the Hindu Kush Karakoram Himalayas together. They lost about 6 trillion tons, and the Arctic Sea is the maximum, because Arctic is, that is how now the lot of geopolitics are going on. Russia is very happy because they can transport the ship through this Arctic. Earlier, because of ice, they could not do that one. Now the retreat of Arctic ice is helping them. It may help them and explore the minerals, because Siberia, they have a lot of part of the Siberia is with them in the Arctic, and then they can explore the minerals and then transport them. They can make a trade via this short route. Otherwise, they have to come all the way and thousands of kilometers. Now they can shorten by 1,000 kilometers, and then they reach all the Europe and other things and supply them instead of roads and all those things. And then the Greenland is losing a lot of ice, and the Antarctic ice is losing 6.5 in this region. Antarctic ice sheet is losing. Antarctic sea ice is losing. The sea ice is very important for climate change. I told you, if we lose this one, then the whole system, that oceanic system, is going to be jeopardized in these regions. The sea level rise will be happening, especially in the Greenland and Antarctica. In these regions, a lot of sea level rise. So if sea level is rising, our Bangladesh, Lakshadweep, all those things you can imagine there. Lakshadweep is already, and Maldives, all these areas are just above or just below the sea level in that region. So even if it rises, it is going to have an impact on them in the system. So if you see that the glacial thickness has reduced, cumulative mean thickness has reduced. That is, we lost around 14 meters of ice in most of the glaciers in the world. This is a really concern. Such is going on like this. This is a really bad trend in these regions. This is how the you can see that climates. You can see the from 1900. You can see up to 1950 and 2000. You can see the sea level is rising, and the sea surface temperature is also rising. Because when there is a sea surface temperature is rising, then a lot of evapotranspiration will be there, and then a lot of cyclones will be formed in these regions, and the temperature over the oceans are also increasing, temperature of the land, because the sea breeze and land breeze will be affected. So if they are affected, the monsoonal system is also, the monsoon system basically work on this system, because when you might have seen that when the farmers say that when their land, dry land and agricultural land, if you talk to, I don't know how many people talk to them during the summer, they form the hexagonal cracks in their paddy fields or the wheat fields. So the depth of the paddy field, the cracks, is an indicator that how strong is the monsoon in the regions. So these are all depends upon them, because the more the moisture, the more the dry, it attracts the moisture from the ocean, and it pulls them up to Himalayas and divert them from Himalayas, and then goes back to the eastern part of India, and the return monsoon will be there. So it depends upon these two land, surface, ocean, and temperature, and then the air temperature near the troposphere, humidity increasing. So we are sea level is rising. All these things are carbon dioxide. You see that one. It is from the 280 parts per million. Now it is going 480, 560. It's keep on going. This is really a problem. And here you can see the snow cover. Snow cover is also very important for the, because without snow, how the ice will be formed? Snow has to be formed. And then the glaciers, the thickness is reducing in the most of the regions, and then sea ice is also decreasing. So this is a very good comparison of all this, what is happening globally in the regions. And then this is how I told you Hindu Kush, Karakoram, Himalayas. So how they help this Kazakhstan, Afghanistan, Pakistan, and China, Tibet, Tarim, all these regions. So we have the Western disturbance, we have the Asian monsoon, we have the Indian monsoon coming in those sides. So this area is having basically three, but it comes, Indian monsoon comes and comes, retreat, yes. So Asian monsoons come from there. And Mediterranean, from Mediterranean we get these westerly disturbances. That westerly disturbance comes up to this, and as a monsoon is having impacting this. Earlier monsoon goes up to here, now it has shifted here. Monsoon, then again it is impacting, especially Ganges maximum in Brahmaputra, it is having impact. Because of Himalaya, it's not going. That's why it's coming back to the system. And then, so in India, the GSA has found that 9,575 glaciers are there. But right now, uh, hardly some 10 or 15 glaciers are monitored throughout India, because a lot of people are not interested or very difficult, or money is needed, or dedicated research scholars, dedicated team is needed. So, but still, remote sensing, a lot of people working, modeling, they are doing, but it is better than the earlier 15 years back, what is there. A lot of people are working. And the winter accumulations in the region westerly dominated, and the headwaters of the Indus is this, several hydraulic projects. All these things, glacier, these are the glaciers. Blue one is the glaciers, basin boundary, Hinduj, Karakoram, Himalayas. This is in the Karakoram. So we can, this is the slide which is shows that how many people depend upon the glacier melt, Indus Basin. So Indus Basin, if you see that with the glacier melt, 41% of the water resource depend upon the glacier melt. So then snow melt is coming to around 25%. So totally it will become 70% is Indus is depend upon the glacier and snow. If you come to Brahmaputra, it reduces to 25. When it comes to Ganges, it reduces to 20. So remaining is monsoon and rainfall and other sources, Mekong and Salween. Similarly, the population, how much population is depend upon that one? That is maximum the Irrawaddy, Indus and all the people depend upon this. Millions of people depend upon the Indus. So low supply of water and high supply. Similarly, you can see the normal years. So this is the glacier and ice melt. So this is the rainfall contribution. So when there is a good monsoon, no El Nino year, so little bit of ice melt is happening. When the drought year, if you see, the percentage is increasing. Dark blue and light blue is increasing. That means continuously, if a drought, continuously sea surface temperature, sorry, air temperature is increasing, then our fixed deposit, that is glacier, ice melt is going to happen. This is not good in the future. It's not good after 20 years you will, or 50 years, you feel that there is no water flowing into the Himalayas. If this trend continues, rising temperature, 0.1, 0.3, now we are fixing some 0.5, but above, again it is, people are, some area it goes up to 1 and above 1.6 also, people are report a rise in temperature in the last 10 decades, 1 decades. So challenges in water security in Western Himalaya, dramatic climate change, we have to take care of low precipitation. Solid precipitation is decreasing. If there is a liquid precipitation, then similarly, it will transfer the heat and melt the existing snow. That is not good for the liquid precipitation in the high altitude regions. So unplanned developments are going on, because we have to look into the economics, look into the people needs. So rapid glacier retreat and melting, and the growth of tourism, there is another one. If you see the Manali, for example, if you go on summer, sometimes you have to wait up to field trip. When you go, we have to wait for maybe 8 hours to cross the Rohtang Pass. So many tourists are coming in that Gangotri. If you want to, from the Gangotri temple to the Gomukh, if you, because you can only go by walk, we will not get the permit to go, because so many tourists to come. So now they are reduced to 100 or 100 tourists per day. So that is also happening. So this is a melting of the glaciers, especially Greenland and Antarctica, having a lot of issues. And then that is actually increasing the sea level in the regions. And also a lot of glacial retreats reported in the Himalayas, Africa, Alps, Andes, and Alaska, Rockies, Cascadian Mountains in these regions. And from 1996, the snow cover has reduced 10%. And so Arctic ice is thickness is lessening and lessening. That is what I told you in the beginning. And then the global warming impacts the physical, the risk associated with some extreme weather events, and then the ecological impacts are there, because you know that then the water is very important for them. For example, if there is salinity increases in the water, that faunas and floras and the keystone species will be died or will be migrated from one place to another, and then it will create a problem. Ecological system will be affected, and then the productivity will be species extinction, and alien species will be coming into that one, and then the sea level rise and other things, then social impacts. So if there is no productivity, people depending on that will be, maybe it's a lake, maybe it is a river, people depend upon it for various purposes. If it is polluted and it is having the DO less than that 7 milligram per liter, then people will be shifting their uh, uh, occupation, or they have to alternative uh, job they have to get, and then their food habit also has to be changed. They cannot grow the vegetables or fishes in these regions. So the large scale impact will be the large scale increase in the temperature, deglaciation, like in Antarctica and Arctica and Greenland, it is happening. So the temperature rise will be having different impacts, even a 1 Fahrenheit. So that's why we call it as a natural climate meter. So if the glacier is healthy, that is, it is not retreating, and then the equilibrium line is still at 3. For example, last year, 5 years back, I measured equilibrium line altered ELA is around 3,800 meters. If you go after 5 years, if you are able to identify the snow line and ELA at 3,800 meters, that means the glacier is healthy. If it is pushed back to 4,800, then that means the glacier is going to lose and it become a museum, glacier museum in future. Widespread imbalance, and then the glacier melt will contribute to the 87 millimeter of rise in sea level. It is regional water resource hazards like glacial lake outburst, like we are facing every year, avalanches, irrigation problem, landslides, tourism, global sea level rise, global this conveyor belt. This is what I'll do. The conveyor belt system will affect it. The ocean, ice-free surfaces will develop. So rising temperature, reduced snowfall. That is, warmer temperature leads to less snowfall in the accumulation zone, reduces the mass, glacier mass. It increases the melting. Then excess snow will accumulation will not happen. Changes in the precipitation pattern, because the local microclimate meteorological factors will be changing. So sea level rise, water security, ecosystem disturbance, land instability. That is, I told you, landslides. When the permafrost is deep permafrosted, then it leads to landslides, unstable, and the border roads will be landslide will happen in that time. So we have getting a lot of visible evidences. The recent also, and historical records also proves that how this compared to the past, the presently the glacier system is healthy or not in the region. So the glacial retreat, that is the I told you the snout, that is the nose of the glacier is retreating, and that is leads to the form the glacial lakes in that region. That glacial lake output the risk. Glacial and water resource management include hazard assessment, earlier warning systems, risk reduction measures. So these are all on theory it is there, very difficult to implement it also, and also that constructions like I told you, dam constructions are going on in Himalayas in order to feed the people water, as well as irrigation, as well as hydropower, because we are getting, for example, Delhi is getting from always from the different sources. Channel stabilization, land use planning, integrated glacial hazard management is needed. Similarly, climate adaptations, that is means we should know how to, if the glaciers are lost, then how to manage the watershed. If the glacier basin is not there, then there is the rainfall, then how to manage the watershed. We have to some adaptive strategies or alternative water resource you have to develop in these regions. And then water efficient technologies like drip irrigations or some other system you have to develop to reduce the water intake into the system, or develop a crop, biotechnologically altered crops, or altered the things which needs less water, which can survive in the stress. People are working on that one in the rice and wheat, with less water, water stress condition, how they will grow, with the, when there is a water stress, then there will be pesticides and other things. Pests will come, how to face it. Effective glacier and water resource management is essential to reduce the sustainable water supply, energy production, water quality, resilience to natural hazards, and so integrated approach. So no problem in the nature is solved by one particular knowledge. Engineer cannot solve anything unless until you have the sociologist, geologist, environmentalist, hydrologist, all those things. So we need the people from multiple subject experts to work to find a solution. So this is how the system works in Himalayas. So Western Himalayas, you can see the influx is winter accumulation that is from the westerlies. So here monsoonal precipitation is monsoon, Asian monsoon is contributing here. So you can see the difference between Indus, Ganges, Brahmaputra, Godavari, Krishna, Kaveri. So annual potential, you can see the potential itself shows that Indus, because we are up to border only. After that, it goes to Pakistan. So we can't. So even then, that is having a 46 billion cubic meter of utilizable flow. When you come to Kaveri, you see that only 19. So even though we are having only part of that in the Indus, it is having more potential. So compared to the Godavari is relatively better than the Krishna. So see the differences between the glacier impacted glacier sources of the glaciers, which enhances the potential of the river and utilizable water resources in the region. So we should study in detail and understand them and conserve the glaciers. So this is again, I told you earlier, the same thing. And that's how this Indus having the glaciated area percentage is 35%. So maximum is Indus, Ganges, Brahmaputra only we are having glaciated area. That's why we are worried. We should deal with study the glacier, understand the glacier behavior of the glacier. So these are the glaciers we are working in from the JNU group in collaboration with the NCPOR, Ministry of Environment, IITs, and all those things. We are working in this one. So we developed these systems. So the Indus, we have the Chandra Basin. We are working. This is the oldest record available in India, which is from 2002. A lot of records are available. Then we are working in the Pacho Glacier and Panchi glaciers in the Baga Basin, in the Chandra Basin, Chota Chigiri, Baga Basin. Then Ladakh, we are working on this Ladakh Basin, Latu, Stock, and Sikkim. We started the Tista River Basin. So this is the longest record, as I told you, available in the Chota Chigiri glaciers. In the earlier we have the annual mass balance. Later we did the seasonal mass balance, winter and summer accumulations, and then we found out that around -8 meter water equivalent of ice has been lost in this region. So we also try to understand how the snowfall and rainfall impacted the glacier health, mass balance of these regions. These studies we are all doing, and you can see that my Google Scholar or the Scopus, our publications up to even this year, there are 3 publications coming in that one. So you can understand how we studied to understand all those things in the different glaciers, how the elevation is controlling their accumulation, how the slope and other things are happening in these regions. So how much amount of snow, glacier melt is contributing. We can do the modeling and also do this, find out how they are contributing. And then the Himalayan rivers, they carry the suspended load and sediment load and water and solute load. And then this Himalayan glaciers are the source of nutrients. So because fractured and grinded bedrocks, which brings high surface area, high reactive area, clay and silt particles, and then suspended materials full of clay and silt, and microbes living in the glaciers plays a crucial cycling, that is the criconites. And then the biogeochemical cycles of these streams are happening there in that one, which supplies nutrient. This is the glacier floor. This is called the glacier floor. That is sediments, biomineralized sediments due to glacier traction methods. So it produces a lot of nutrients to the downstream lakes, rivers, and agricultural land in these regions. So with along with micronutrients, macronutrients, trace minerals, and clay soils, and it has a neutralizing capacity of the soil acidity in the region. So this is also we are studying to understand the criconates role and the black carbon role in the albedo changes, which is affecting the glacier health. More the albedo, more the black carbon, then the glacier will melt faster in this region. So we are also trying to study using the expertise available with the students on the biogeochemical cycle and the microbiology in that regions. So the criconate holes, which is there, you can see that in the glaciers, is a shallow area, it will be there. It will have the potential to fix as much as 64 gigagram of carbon per year. So it's nutrient rich parts are there because of the bioaerosols which falls into that one, and then the productivity increases in the regions. So this is how this impact of dust, black carbon, and pollutions are affecting the entire region global. Some examples are given. That is in the about 14% of the Arctic is warming and 20% the Arctic snow and ice lost due to black carbon albedo. So, and then the snow cover is reducing in these regions, and then glacier melt is enhanced due to this black carbon. So, so every part, Greenland, everywhere is affected by this because the transboundary, because atmosphere is not having a nation's boundary, transport from the one place to another, teleconnections, impact of dust, black carbon, other pollutants are less studied. Now accelerated, the study has been accelerated. So, and then if you see the cold arid regions, now it become a union territory. But this is having the currents, less solid precipitation. This is happening there, and then no sufficient water during the crucial early months in the Ladakh region. Sufficient water during the midsummer. End summer water is wasted because no agricultural activity is there. Because of changing climate, they are not able to. They developed these artificials and ice stupas in these regions to conserve the water. So another one is that Karakoram anomaly. You might have seen. You may not be interested in that, but this is very interesting for us to why this glacier is not a glacier in the Karakoram, which is in the Indo-Pakistan border, highest battleground between India and Pakistan. So maybe due to these regions, they are positive, they are not retreating, they are healthy. Maybe unknown factors more than the due to logistic issues. Mostly we are using the modeling and remote sensing too, and also it is a sensitive area. So maybe due to the increase in snowfall, low temperature, and glacier health, all those things. So if you study this glacier, you will be able to know how the resilience of the glaciers, how they resilient and come back, bounce back. These things we can study. And then the rock glaciers, which is very important for our water resources, which is often covered a thick layer of rock debris, making look like a traditional glacier found in high altitude. Below that, ice and snow will be there. Because of the avalanches, the rocks will be falling into that one, and then they act as concealing the snow and then reducing the impact of surface temperatures. And then they form due to the ice core holds the rock fragments together, allowing the glacier to flow. And then the ice fills the spaces between the rocks, binding them and enabling. So this is something in the climate change time. Rock glaciers are helping us, and the movement is slower. And then it is having a lot of important water resources in these regions. It stores a lot of water in between debris, and slowly, due to insulation effect, it slowly releases the water, and it is transferred less and then transferred to them. So water stress management, we have already discussed in that one. So the population is increasing, and then agricultural food productivity has to be increased. So we need a lot of water, we need a lot of electricity, and also the fishes. For example, fishes are also not able to survive. Trout fishes, for example, they are not able to survive in the Himalayan streams because during the summer they want to go back, jumping back to the cold regions because of the dams and other thing. They could not go, and ecosystem is affected, and then the bioresource systems are also affected. So water stress management is very important, and then the social impacts and environmental impacts happening to that, and glacial outlet bursts are also happening in the system. So this is how this Teswang Norpal is a Padma Shri who developed with his local knowledge as a local engineer. He developed this horizontal water artificial glaciers. So it is having a largest advantage than this other harvesting of the glaciers, because this larger area, and moreover it is rain shadow, and it is in the northern side of the glacier, so that the sun rays will not fall into that one, and it stores it and releases slowly during the summer, and then the villages will get out of water for the drinking and agricultural purposes they need. And another method they do is that conservation, that is he also got award, Sonam Wangchuk, for this ice stupas. But here people are telling that is very expensive, and also you have to use a lot of electricity to pump the water to this, spray the water in these regions. So they are constructed at higher elevation, can store good amount of water. So, and there are two ways by which they are conserving these glaciers in the region. So, we used to study the paleo climate in the mangroves, in the tree rings, in the lakes. We get a course in the lakes, ice course. We take it and then try to identify all these things using this. So we used to have monitoring stations. This is a snout area, nose of the glacier, a discharge station. This is a bridge we developed to monitor the discharge, and then the snowfall and rainfall pattern, wind directions, all those things we measure. And we have the AWS also we installed there in the regions. This is the criconites. You can see that one, which is playing a major role in albedo, bioalbedo, and nutrient transport in these regions. And this is how this Lake Chandratal Lake, famous lake, you might have seen by tourists. And we develop all the systems. And thank you for your patience. And if there is any queries, you can.
Thank you so much, sir, for such a wonderful talk, sir. We have learned a lot from your talk. Audience, if you have any queries, any questions, you can ask me, sir.
Sir,
Uh,
so it is really a very informative deliberation, and also a matter of grave concern that the glacier is depleting worldwide.
yeah.
Sir, I am an inhabitant of Brahmaputra Valley, Assam.
Okay. Yes.
And you have mentioned that the dam construction in Tibet will have impact on Brahmaputra.
Yes.
Sir, am I audible?
Yeah, you are audible. You go ahead.
Hello.
Yes, I am audible. Yeah, your voice is audible.
Okay. Thank you, sir. Sir, you have rightly mentioned that the dam construction in Tibet will have impact on Brahmaputra.
Yeah.
Sir, will you please elaborate what type of problem we may confront in the future, or what we can do to save our Brahmaputra? Because I'm an inhabitant of Brahmaputra Valley, sir.
See, you can go to the Google Earth also. You can see that how the dam is developed on the Tibetan side, where there is Sangpo River comes and take a U-turn towards India. So they are building a dam. It is not finished yet. That is a diversion dam of 1.5 kilometer and very deep, maybe half a kilometer deep, or all those things. So they are constructing to divert this water which is coming melt from the glacier mills of the Tibet. And then it may not happen in now in 1 or 2 years. After 5 to 10 years or 20 years, it will happen. If the flow of water is not coming, only the limited water is going to come to the Brahmaputra in future. We have a lot of objections raised in the United Nations and all those things. But you know very well that one country cannot stop other country, even though you do argue a lot of things in that one. So if the water flow is reduced, Then what will
That's
perenniality will be going, na? Then only rainfall, wherever monsoon comes, then eco-hydrology will support the Brahmaputra, not the glacier system. But the water flow and the availability of water will certainly reduce.
okay. So actually, as you know that Assam is a agriculture based state, so there will be definitely impact on agriculture also, and also it is a biodiversity hotspot area, so biodiversity will also be affected.
Yeah, especially when the monsoon is active, then it will be biodiversity may not be affected much. Agriculture maybe in the non-monsoon season will be affected in that one. Where especially in the drought and the El Nino year, you will face the problem. If the dam is constructed, we are objecting. They say that we stopped something. We don't know when they are going to complete, when they are going to start. You can see the Google Earth how the construction is going on and that.
Yes, yes. Thank you, sir. Thank you very much.
Okay, thank you so much, sir,
Yeah.
for such a wonderful talk. And we will meet again, sir, at 11 a.m. for the next talk, sir.
Okay, sir. Thank you, sir. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank
Thank
you,
you.
sir.
Thank you, sir. Very
Thank you,
nice
sir. Thank you.
information.
Thank you, sir.
Thank you.
Thank you very much, sir.
Thank you, sir.
Very nice and informative talk. Thank you very much, sir.
Thank you.
Thank you very much, sir.
Thank you, sir.
اور کیا؟ ٹھیک رہے سر. بتا لوگ باغ جو ہے نا وہ ہم لوگوں کو اتنا وہ نہیں سمجھتے ہیں. اب کرو بھیا میں